Okay, should be working now. All right. Sorry for the delay, guys. So the calendar shows the current week that we're in. We're going to do 1.1b, the second part. This is going to be a bit more challenging. Today's class is a bit more interactive than typically. It's more lecture-based than it is interactive-based. And anytime we do, dare I say, word problems, the class will be like this. My first quiz in pre-calc is always the only thing I do that day. Is it's not going to be an entire class period of a quiz. I just want to make sure we start off on a solid foot, everybody with good grades. So I always make that first quiz, just that's all we do that day. So notice, I mean, the only thing leading up there is just section 1.1 and 1.2, even though I'm going to teach those in 2 days. It should be an easily passable quiz. So here we go. The homework tonight is there. There's one note here, and it says convert miles per hour to feet per second to make it easier. Or I think it's actually, you have to do it to feet per second. For number 68. I just taught this previous class, and the kids had enough time to get all the way through to 64. So once you get a good feel for what this is going on, it's not that bad of homework, but some people always have high anxiety when it comes to word problems. Anybody high anxiety already? Like the homework was just killer? Well, then you'll be fine. You'll be fine. I mean, you should have anxiety in the sense of like, it's unknown. You don't know what's going to happen. I mean, having some anxiety is, in my opinion, a little bit of a healthy thing, but high anxiety, we're not there yet. We get to trig, that's high anxiety, but we're not there yet. Even tonight's homework, okay, they're going to be word problems. Some of them you might not get, but tomorrow will come, I didn't get number 14 or whatever, and I explain to you like, oh, why didn't I get it now type thing. Word problems are always like that. The ones we do in class today, I'm going to get to a point, you're like, oh, okay, I get it now type thing. It's like a geometry proof. Everybody good? We're ready? Actually, I did give you a book though, right? Okay, cool. All right. Remember the same homework expectations. I'm giving you the answers to everything. All of them require work. Although I will say some of those distance and midpoint you probably could have done in your head because they were integers. Others that aren't integers, not so much. So this is the application of the distance and midpoint formula. To insult your intelligence, we'll go over, but remember red square, you're going to copy something down. Blue squares, we do one together. We're going to do them all together today. Green square, I'm not going to give you any problems that you do by yourself today. All right, here we go. Recall from the last class. Recall from last class, we dealt with 2 formulas. Julia, distance formula, top of your head.
B equals the square root of x minus x minus x1 squared plus y minus, oh wait, okay,
You got
how
it.
do we do that? Okay, x1 minus x2, right, squared plus y1 minus y2 squared. It's like going off my head.
Okay. I will say the book writes x2 minus x1, but when you square something, does it make a difference? It's always going to be positive. You're doing distance measure positive. So if you want to remember it as x1 minus x2, as long as you always do it that way, that ends up being fine because you're squaring. The book will say x2 minus x1. Here's the big complicated thing. Cammie, we had a whole class on this that you didn't see, but it's just the distance formula. I'm just going to show you and remind you the formula. So if I give you 2 points, P1 and P2, then this is the distance formula. And once again, I mean, x2 minus x1 squared or x1 minus x2 squared, it's the same number. But what you can't do is you can't flip-flop. If you want to do 1 minus 2 on the x's, you got to do 1 minus 2 on the y. You can't, don't flip-flop them around. Yes, everybody? Okay, we already did homework on this. Not that I want you to do this in your head, but if the numbers are easy enough, you can do this. You know, for pre-calc students. For alpha 2 and lower, we write everything out. The key to doing this is labeling correctly. And once again, it doesn't matter how you label them. Just one of them has to be 0.1 and one of them has to be 0.2. Then you have an x coordinate of 0.1 and a y coordinate of 0.2, and away you go. I like to stack the ones, and I'm always bottom minus top, but some people like top minus bottom. It doesn't matter. 2 minus 3 is 1. 1 squared is 1. 4 minus 8 is -4. -4 squared is 16. So it's 1 plus 16, which is 17. And there's a big square root, so it's the square root of 17. No perfect squares in there. No, you don't need to do it as quickly. I mean, you can methodically go through this. Just remember, distances are always positive because there's squaring involved. It's Pythagorean theorem. Last step is remember, get rid of any perfect squares that are inside the radical. Tonight for homework, they're going to be real world problems. So they're going to want to know, well, what's the real answer type thing on many of the problems? Like, how far is it from here to here? Well, that's kind of like in feet or miles. So square root of 17, you say somebody, I needed to walk the square root of 17 to a pre-calc student, that's fine. You know, about 4 point, somebody, 4 point, take a guess. She's guessing 4.2. 17 is awfully close to 16. The square root of 16 is 4. So 4.2 isn't a bad guess. So what is it? Anybody? Is it 4.1? Okay. So if you grab your calculator, it's about 4.1. All right. The second formula was we had midpoint formula. So Abby, what was the midpoint formula?
I don't remember.
Do you remember any part of it? Give me anything you remember.
Oh, was that the one where you have to divide it by 2?
Yes.
Yeah, so it was x1 plus x2 divided by 2, and then like y1 plus y2 divided by 2.
Do I do anything with those two numbers then?
I don't think so.
You put a comma between them,
Yeah.
because remember, midpoint, you're finding an actual point. You're not finding necessarily a value. Here's a slide that makes it look way this is how we proved it, remember. Remember, what it really is finding the average of the x values and the average of the y values, because that's where the midpoint is. It's smack dab in the middle, type thing. So given the 2 points again, here's your formula again. Questions? All right. With that out of the way, now we're going to see some applications. This will be painful. Some of you are going to get this way before others, and others of you aren't going to get it until you get that one little key bit of information, and then you'll be like, oh, okay, now I get it. As I stated before, I'm going to try to pick some examples that are just like what we do for homework. Okay. Oh, I'm sorry. The midpoint of this, anybody do that in your head real quick? The average of the x's, and it's the average of the y's. Nobody? Give me the average of the x's. No.
No, because you can't just add a negative in the
Sure you can.
definition of positive, don't you?
What?
In order to get a midpoint, you
It's
have to get
the-
the entire distance, and so
If I'm 10 and you're 20, what's the average of our ages?
15.
You didn't worry about one was positive or negative. You just add the two numbers. Yeah.
Is the average of the x's -3/2?
Yes. Or I was waiting for somebody to say -1.5. Either one's fine. Average of the y's. That was the easier one, right? Yes, I'm going to do a lot of this. What do you think it is? Do it in your head. We're not a basic level math course. No, when you're really doing this, do I truly expect anyone to not do this by hand, not maybe grab your calculator to confirm type thing? But we got to stretch our legs here in higher level math and force ourselves to be a little bit uncomfortable at times. So when I ask you to, what do you think? You know, I'm really asking for an answer, and I truly want to see, can you do some of this in your head? Yes, you were right. So -3/2 and -5. All right. So today we're going to be taking those two formulas, distance, midpoint, and we're going to be applying them to something called applications. The book just doesn't want to say the word. That nasty word right there, word problems.
Really?
So you can throw a temper tantrum for a second or two, but yes, you have to do word problems. We'll be doing lots of word problems, and especially in calculus, all right, all the time. All right, so we'll start off with a nice, easy one, and we'll work ourselves up to challenging. Some of these will be challenging, and this is a group effort, so I'm gonna try to tease some information out of everything. Some of these are easy, some of these are hard, and some of them can be done multiple different ways. All right, Gabby, you're the guinea pig. You're my reader. Read.
If the point.
By the way, it's example number 1 on the box in front of you.
The point 2 and 5 is shifted 3 units to the right and 2 units down. What are the new coordinates?
Okay, what do you think?
Uh,
We'll read again then.
what? No. Okay, wait. Maybe my other one.
No, just read.
Why? Okay. If the point 2 and 5 is shifted 3 units to the right. and
Stop.
two-
Read that one more time. You didn't read wrong.
If the point 2 and 5 is shifted 3 units to the right.
Stop. So what do you think that means? Use your own words.
So then you change 2 to 5.
Okay, I was hoping you'd give a bit more, but you're kind of seeing now this isn't as bad as it looked, right? So tell me your thought process there.
Because 2 is x, and if you're shifting to the right, then you're moving 3 to
Then the only thing you're changing if you're shifting to the right is the x-axis. Okay, read the rest.
and 2 units down.
Stop. What are you thinking now?
Would be 3 instead of 5.
You're giving me answers, but yes.
What am I supposed to say?
No, yeah, I mean, you got right. I'm just wanting you to like flesh out the explanation.
Because 5 is y, and if you're going 2 units down, then it'll make it 3.
Right? Anybody? Different way of doing it? It's probably what I would be thinking as well too. You want me to make this complicated for you? So here's what she said, although she immediately said the answer, right? Here's what she said in mathematical terms. I made her stop at the first one, 3 units right, and she gave me the answer. So she said, well, it only involves it only affects the x value, and the x value of our original point was 2. And if we're shifting to the right, that makes it moving to the right. That means we're adding, not subtracting. So we take the original x value, we add 3, and the original x value was 2. Same thing that I had to read the second part. Well, going 2 units down only affects the y value. If I'm going in a downward direction, I must be subtracting. So I take my y values and subtract 2. So putting that all together as a point, here's your x coordinate, there's your y coordinate. Well, there it is. Now just do the math. So take the original 0.25, 2 is your x, 5 is your y, plug it in, and get your answer. Okay? Yes, you'll have a problem like that tonight at homework. Feel confident you got that one right. Yay or nay, everybody? On that one, I think that's the first one I gave. Okay. Want to do another one, or you got the idea? You got the answer immediately. I didn't. All I had to tell you was read it slower. Like that was it. Right. So let's see. Key takeaway from this number 1 is read it. How many times should you read it? I don't know how many times, but it better be until you understand it, right? And as soon as she understood it, all of a sudden there was the answer. But the only thing I made her do was maybe read it in chunks. I don't know what the whole thing means. It's too complicated, but read a little bit slower, read it into a little part, maybe until you get to the first comma, maybe, or something like that, until you understand. Does that make sense? So read it multiple times, read it in chunks. We're going to jump right to a challenging ones. I would be surprised if anyone could get this without a little bit of help. Landon immediately is paying attention because he's like, I'll prove you wrong. So I guess Landon, oh no, Holler, I'm saying, right? We said the other Landon's going to be Landon, you're going to be Holler. All right, so this is pretty simple and you'll get it. Everyone in here will get it, but not until maybe you get a little bit of help with it, okay? When I show you the answer, oh yeah, I get it, it makes sense now. All right, Holler, read.
Find all the points on the x-axis that are 6 units from the point 4.
Read it one more time.
All the points on the x-axis that are 6 units from the point 4, -3.
Okay, well, that's a pretty short sentence. This one's challenging. And you'll see why here. So what are you thinking, Holler?
I'm thinking 10, -3. And -2, -3.
So he's immediately going to throw out an answer. Okay.
Saying just 10 units in general, not necessarily saying.
Say that again.
It's saying 10 units in general on the x-axis.
Where are you getting 10 units?
Or sorry, 4, 6.
How about 6, right? So what he's saying,
I think
Holler, is that it might have been true with Gabby's one. If we were just shifting directly left and directly right, we're not shifting directly left and right. How do I know that? Where's your starting point? Is that on the x-axis? Sure, we know. You know where 4, -3 is.
Oh, wait, yeah. You do.
So is that on the x-axis? 4, -3 lives on the x-axis.
I has
It
to be
isn't.
0.
It isn't.
It isn't. If we had lived on the x-axis, then yeah, going 6 units in one direction, that would just be a plus or minus 6. We don't live on the x-axis. Thoughts?
Was that wrong?
Oh, way wrong.
I think it's gonna be,
I would be highly surprised if somebody could do this in their head.
7, 0, and 1, 0.
I'll go back to my statement I just said. I'd be highly surprised if anybody could do this in their head. So when you're stuck, we need another technique. So the Gabby technique was to read it a bunch of times. Well, we've read it a bunch of times. So we need a new technique. Somebody, anybody? Say it again. When in doubt, draw a picture. So let's draw a picture, Holler. What are we drawing? Well, I don't see a triangle up there.
Oh, coordinate plane.
Okay, so I need a coordinate plane. What else do you want me to put on it?
4, -3.
So he wants me the point on it. Anything else from the setup?
6 units.
Okay, so he wants me to, this is a very good pre-calc question. It probably can't be done in your head, but we got some good ideas. So when you're stuck, always draw a picture. So he said coordinate plane. I put 4, -3 on it. Yes? Anybody else? Something I should probably draw?
2 points for.
Well, I'm going to read what it says.
Yeah, 2.6 away from the center.
I'm going to read what it says. What does it say we're looking for? So what should I draw or highlight? I should probably highlight the x-axis. Now Holler said, well, I know the points where they basically should be, not exactly, but where should the, by the way, how many answers will there be? 2. And where do they live? Could I roughly draw that? Okay, I'm gonna roughly draw that. I'm drawing exactly precise, but you won't know where these points are, but we know roughly where they are. If I'm 6 units away from A, and I know I have to live on the x-axis, well, I gotta live somewhere like right there, right? And then another one on the other side, yes?
I was thinking a circle.
Yeah, agreed. So a circle would be one way. Do we know the formula for a circle?
Pi 2 r.
What?
Or sorry, the formula for a circle.
For any points on a circle. Do we know that formula yet? Do we know that formula? You probably learned it in Algebra 2. By the way, section 1.4, which is Thursday or Friday, I think, will be circle formula, but we don't have that one yet. That would be a way of doing this, by the way. Okay, great. I need to find where that point and that point is. Now, granted, I drew it precisely, and those are, notice, it's not going to be a nice friendly number. No, we're not doing about, we're going to find precise. Well, he's saying it's 9 point something and it's negative 1 point something. Thoughts, anybody? Well, where does this point live? Well, I know something about the x-axis. Be the 0 on the y, right? So I know that that point right there is going to be something with a 0, and that point over there is going to be negative something with a 0, right? I'll just call it x2, right? I know it should be negative though, right? Okay, I made some progress. So ultimately my goal now is to find what? The x, right? This x on x1 and this x on x2. Okay. This, up to this point, you should have been able to get. Even if you're like, I couldn't do that, but I'm saying, if you sit down long enough, that should be the basic picture. It's the finding the x that's kind of the tricky part. Thoughts? We could use a distance formula, but we don't need to find it because we already know this distance is 6. We're told that, right? The distance between the two black dots right there, okay, that would be interesting, right? I can't figure out that distance until I find what the x's are. Anybody else? How many people took geometry last year? Okay, what would I always say in geometry class? You're in a high school geometry class, what should you do? Make triangles. Hey, I got a triangle. But I didn't say make triangle. What would I always say? You said it already. Make plural. Make triangles. Okay.
Line from the x-axis to the A plane.
He's saying an easy thing to make 2 triangles would be to draw a line from. That would be pretty easy. I've now created another point right here, but guess what? Do you know where that point is?
It's the midpoint.
Got to be the midpoint, right? But what is that point right there?
4.
4.
It's got to be 4, 0, right? I mean, I know where that point is. It's at 4, 0. And this is usually like, okay, I can kind of see what I'm going to do here, right? So I got a bunch of options. Maybe I could use the midpoint formula. Maybe I could also use Pythagorean theorem. Now that I have, hey, this is 6 and this is, how did I know this is 3, by the way? This is at 4, -3. So this is at -3. It's at distance wise, it's at 3. The point's at A is at 4, -3. Okay, cool. So what do we want to use? Distance form or midpoint? What do you think? Anybody? Let me label. Pythagorean theorem. Let's use Pythagorean theorem. So in other words, we're finding. Are we doing, when you use the Pythagorean theorem, are we doing distance or midpoint? We're doing distance. We're going to find the distance between 4, 0 and these x's. And you already said that's the midpoint. So both sides would be exactly the same distance wise, right? You might remember from geometry, hey, look, it's a isosceles triangle. And if you cut it directly down the middle, then it breaks the 2 parts in half. We proved that in geometry. Okay, you're on. Can you do that one in your head?
It's 36 minus 9.
Which is?
27, yeah.
Okay. Why am I saying no to that, even though that's right? Square root of 27. Yes, you can. You should not need a calculator for that. Square root 27, reduced. Somebody's saying it over there. Therefore, it would be 3 root 3. Everybody shaking your head, yes. 3 root 3 for square root 27. All right, here's that work. All right. Math. More math, reduce 3 root 3. Now, where do you want me to put the 3 root 3?
We're gonna add that.
Hey.
Subtract.
Okay, so which one do you want to do first, x1 or x2? Okay, so if this is at 4, 0, where's my new point at? Gave me a point to the point on the right.
7.
Oh no,
Oh,
tell me what you're doing in your head.
I'm adding
The distance, which was
3 root 3.
2.
So is it just 4 plus 3 root 3 comma 0?
That's it. All right. So if that's 3 root 3, and we add the 4, it's not 7 root 3, right? It's 4 plus 3 root 3, comma 0, which is not a very nice answer, but that is the answer.
And then
Right.
the opposite one is just gonna be subtract 42
From
4.
4. Okay, so there's your first answer. There's your second answer. Very unsatisfying answer, right? Because you really want to take your calculator. By the way, what did we say the answer was going to be? Roughly, when we looked at the picture? When you looked at the picture, you're the one that came up with the estimate.
It's gonna be 9.9.
Grab your calculator, do it. 4 plus 3 root 3. And we get, you don't even know you didn't grab your calculator, or did you already do that?
No, this is his.
Okay.
I didn't bring mine. 9.1.
Okay, now do the other one. We said the answer should be about negative. Don't guess, grab your calculator.
Negative 1.1.
Okay, so did we get a reasonable answer? Right, we did, right? So there's your first answer, there's your second answer. You know, we did the actual math at the end there to see if we got. All right, that is the most challenging one that we will do for the day. But hey, I'm gonna go back to this picture right here. As soon as we drew this black line here, was it a challenging problem? No, it just kind of fell into place. What's another way of asking this question a different way? What's another way of asking this question a different way? Just guess what tonight you're going to have for homework. It's going to be from the y-axis. So your triangle is going to be turned sideways. It's the same problem. It's just going to be the y-axis instead of the x-axis. I don't know which number it is, but that's what I made. Okay, that makes sense? All right, that was the hardest one that we'll do. The rest of them are not that challenging. We'll have one that's called challenging, but it really isn't that bad. All right, and this is, honest to God, that's a pre-calc question right there. Right? Woo! All right, how about a medium one? Who am I picking on now? I didn't already picked on you. Oh, the other Landon, thank you. All right, the other Landon, read. By the way, this is box number 3.
The midpoint of the line segment from P1 to P2 is negative 1.4. If P1 equals 3.6, 1.2.
You can get lost in just the sentence because there's like P's all over the place. There's numbers all over the place. So Landon, what are you thinking we should do so we're not confused? And you definitely want to draw a picture of this, right? So maybe like, just be careful. Make sure you read it nice and carefully. So what do you want me to draw, Landon? The thingy.
Yeah, you know.
The coordinate plane. All right. Now what? Is P1 an endpoint or is it the midpoint? P1's an endpoint. What else am I drawing?
The distance from P1 to P2.
Nope, we don't know that. We could probably figure that out, but we don't know that. What else are we given? The midpoint. So as you read this, if you're not reading carefully, this first number right here, negative 1.4, is that P1, P2, or the midpoint? It's the midpoint. You can quickly get lost if you just draw it backwards. Okay, so I'm going to label that one M, right? Just so I don't get confused. So Jade's already trying to solve it for us, right? Who am I picking on? Still Landon or somebody else? Jackie? There's many different ways of solving this one. And I can think of at least 3 different ways. You're going to think it through and we're going to go down whatever route you choose. Ultimately, what am I trying to find? P2. And we can kind of, Cam, you're not going to see what I'm drawing here, but I'm just kind of guesstimating where it is, right? This kind of looks like where P2 is, by the way it is, right? I'm just kind of guesstimating, but we don't guesstimate in pre-calc, right? We got to find the exact answer. So what are we going to do? And if you're listening to Jade, he already gave us one possible answer. So like no idea whatsoever? Well, let's think it through. What are we given? We're given a midpoint. What's a midpoint? It's a point in the middle of this segment right here. So if this is in the middle, then what do you know about this piece and this piece? They're equal. Do we know how long that piece is? Could we figure it out? We could using the distance formula. Not sure if that's helpful, but we could do that. The issue is if it's a distance, let's just say it's, I don't know, it's bigger than 2, right? 2 units. So let's say it's 2.1, and this is P. Knowing that that's 2.1, is that going to help us find this point? Maybe, maybe not. Give me some other thoughts. Should I say it? Presley, what am I gonna say? Let's make some triangles, right? So Jackie, where do we want to make some triangles? Are there any triangles right now in the picture? Let's make some triangles. So where do you want me to make a triangle? I got 2 points. Where's the obvious triangle?
Above where the 5.
Okay, she says make this triangle right here. Okay, I like it. It's not the one I would make, but I like it. Okay. We know the other point lives below it. Is the triangle that we make now going to be the same or different as this one? Okay, if that's the midpoint, right? Think about a bigger triangle, right? If I find the midpoint, what do you know about these 2 triangles? They're the same. We even had it as a theorem in geometry. So therefore, if I draw this second triangle right here, it's got to be the same. I'm going to draw it probably the way that everyone else is thinking, Jackie. Most of us were thinking about this triangle. If I extend this down in this direction right here, if the triangle I make for this part is it going to be the same as different as this one? It's going to be the same. So to go from here to here, I went how many? And then I went. So all I need to go is go down 2 and across 2, and I've arrived at the second point. You could. But you have to determine what the rise of the run is, which means, as Landon said, we need to draw the picture first. Okay, that is a geometric way. Cammy, you couldn't see what we did. We just basically drew 2 triangles of the same slope and apply that. That was probably the easiest way. I will give you an algebraic way because that's nice when these are nice, friendly numbers. But if they were ugly numbers or square roots or even variables, well, you couldn't do that. So here's an algebraic way, right? The algebraic way is to use the midpoint formula because we're given the midpoint. We know M for midpoint is an actual point, X and X comma Y. And we know that of the formula on the right side of the equal sign, that x1 plus x2 over 2 only refers to the x value of the midpoint. And then the y1 plus y2 over 2 only applies to the y value. So I could actually split that thing apart. This is an algebraic way of doing the same thing. Okay? So those 2 things in red go together, right? That'd be 1 equations, and the 2 blue things, the y would go together. Now let's plug in what we know from our problem. There's our problem. We know the midpoint is at -1, 4. -1 is the x value, 4 is the y value. So on these 2 things in blue here, these 2 equations for the x and the y, not the x1, y1, right? Just the x and the y, I could throw in for that x and the y, I could throw in those 2 values. Okay, I'm going to split this now equation right up here into 2 parts. There's the x part, and there's the y part. Now, where did I get the -3, 6? Well, that's my point P1 that I substituted into the x1 and the y1. Hey, now it's just an algebra problem. What do we do to both sides? Get rid of that number. Multiply by 2, so that's going to give me -1. Multiply by 2, and that's going to give me an 8. And then it's a simple algebra problem. And we did arrive at the same thing, 1, 2. Which we arrived at making triangles. So I'm showing you 2 different techniques. I'm not going to show you the technique where you actually calculate the distance. It's an ugly number. It's got a square root in it, and it just makes it a bit more complicated. Those would be the 2 basic techniques that I would use. First technique, just continue the rise over the run if you're given the midpoint. And the second one is if you want to do it algebraically, well, then it's not that bad algebraically. Did that make sense? Me personally, I would have gone with making the triangle thing. But if they told me that this was some god awful number or it was variables or something like that, I'd probably use the algebraic. Okay. Concerns? Panic? Okay. You'll have a problem like that tonight for homework as well. So 1, 2 will be the answer. All right, how about an easy one? Yeah? Yeah, Chloe wants an easy one. All right, you're up, Chloe. Chloe, you ever watch baseball? Okay. Did you know that it was a square? Okay. I always thought it was a diamond, and I thought it was a kite or something like that. I mean, not all kites are squares, but all squares are kites. Yeah, I said that right. Not all kites are squares, but all. That's not even a true statement. I said kite, I meant diamond. We say rhombus, right? There, okay, so here we go. Not all rhombi are squares, but all squares are rhombi. There, I said it correctly. I don't know why I was thinking of kites. Yeah, it's a square. Okay, Chloe, what are we gonna do? She says draw it. So can everybody in their mind picture baseball? Right? Yes, no? Nate, can you draw it? I'm not gonna ask you to actually draw it, but can you picture it? Right? Probably should. Okay, there, I just got that off the internet, right? That thing in the middle, that green part, it's a square. It just turns sideways. So they call it a diamond. In math, we would call that a rhombus, right? Okay, Chloe, you're on. Keep going. What key piece of information do you see up there in the words? That's not on our picture. So where do you want me to put 90? Between what two bases? She said between home base and second is 90 feet. Yes? Jackie's shaking her head no. Is actually 90 feet on a side. If this is the diamond, where's the sides of the diamond? Yeah. Between each of the bases is 90, right? So you could write 90 all the way around the square. I'm going to suspiciously choose that one and that one. I could have chose the other two sides. It doesn't really matter which one. Okay. Suspiciously. Ultimately, Chloe, what's it asking us? Ultimately. The bottom of the triangle, I don't even see a triangle yet. So I need to make a triangle. Where do you want me to make the triangle? Cut it in half, connect what to what? I like that. Okay. One more question, I'll leave you alone. What kind of triangle did we just make? Absolutely, it's isosceles. Any other kind of triangle we just made? Thank you, Chloe.
Sorry, I thought you were asking the class.
I'll say class. Chloe? How do we know it's a right triangle? Yeah, that would be kind of as a result of it. How do we know 100% that it's a right triangle? And it is. Does it say? Not all isosceles triangles are right. Some of them are. It's a square, right? What do we know about all the angles of a square? So therefore, third base right there is 90 degrees because it's a square. So it's a right triangle. Okay. Lizzie? Now what?
Oh, you can put it in the other ones are 45.
Okay, what are we ultimately trying to find here?
Oh, the distance between the put in second.
I like it. Keep thinking. She said she wants me to now connect first base to third base, and now we have 45-degree angles. Nothing wrong. I mean, that's true. What are we trying to find?
Distance to 100.
Okay, so that's the hypotenuse of that triangle. Yes? Keep thinking and talking. How many people already know what we're about to do? Okay. Do what? Keep thinking. Abby, what are you thinking? I'm trying to find the hypotenuse, that red line I just drew.
Oh, could you use the theorem?
Were everybody thinking that? Yeah. Granted, not nice numbers there, so what's the equation?
90 squared plus 90 squared equals.
Guess why you got a calculator this year? Because the numbers won't be nice. But that is the point right there. As soon as you're like, oh, it's a right triangle. Oh, I'm trying to find the hypotenuse or one of the legs. I can use Pythagorean theorem. All right, everybody grab your calculator. Go. I want to know, how far is it from home plate to second base? By the way, that's how far the catcher has to throw when somebody tries to steal second base. How many people got an answer? Look what you got. About
7.28 feet.
so about 127 feet. I'm only laughing because he gave me 2 decimal places. Yeah, 127 feet. Yeah, it's 90 squared plus 90 squared. Big numbers. You need a calculator to do all that, right? No one's going to recognize that there's a perfect square inside of 16,200, generally speaking, right? What? Say again? Is it? Okay. Square root of 81 is 9, and then there's a 10 in there somewhere as well too. Oh, because it's 200, so there's 100 in there, right? So 100 times something else, so about 127 feet. Okay, wrapping it up. We're gonna go around the room. So Parker, I got a word problem. Give me a technique we're gonna use. Well, exactly. You got a word problem and you're crying because you can't get it, right? Not you, but you know. What are you gonna do then? You can't sit there and cry for too long. Maybe there's some triangles, right? Jack, give me a technique that we use today.
Midpoint.
Okay, maybe use a formula that you know. What do you got, Landon? Draw a dang picture. Make your life easy. You got to draw a picture. All right. I will see you guys tomorrow. All right. Here, Cammy, where Mr. C's theorem is, use whatever formula was in that section. Right. You should now have enough information to get this done. There is your homework. Just a quick hint on number 68. Convert the 15 miles per hour to feet per second. You can either Google that or you can calculate it yourself. If you have any questions, send me an email. Where is? I thought I was in the meeting. How do I stop it? See ya. I haven't used Zoom in so long, I can't figure this out. How do I stop the meeting? Hey.